Hello, everybody. My name is Russell Herbert. For those of you that don't know me, I'm the industry principal for oil and gas for OSIsoft, and I'm based in the UK. Delighted to be here. Today, I'm going to be talking on the topic of best practices, or at least some suggestions for operational data management in oil and gas. So the first question, why are we talking about data management today? It's not really the most sexy topic. Well, the reason is that there's a real growing interest in the industry for this particular topic. I see an increasing amount of articles. I hear a lot of people discussing the topic. And I think, and I agree with everyone, that it's a really important thing. We've all been collecting data from our operational assets for a long time. We're very familiar with the idea of tags and data historians and this kind of stuff. But as we increasingly look to operating in a more advanced way, I think it's important that we spend a little bit of time looking at how we're collecting and managing our data, and maybe think about ways that we can improve this to make sure that we're maximizing the benefits available from all this new technology. So in order to think about how we can maybe improve, or some suggestions for doing things slightly better when it comes to managing our data, I think it's important that we first have a look at how we've been traditionally collecting and using data in our oil fields for quite some time. So if we look across our assets, we're all familiar, there's lots of pieces of equipment that are generating data. Topsides, wells, subsea infrastructure, controllers, terminals, you name it. Lots and lots of things generating data. And generally, this information would come through our process control networks and end up in a piece of technology that we're all familiar with called a real-time data historian. And as operators, what do we do with this historian information? Well, we do many things. First thing we do is we buy lots of different types of applications that need this kind of data to help us run our oil fields. Hydrocarbon allocation systems, modeling systems, flow assurance systems, specialist tools that take data from our oil field, analyze this, process this information in a certain way for us, and present it to us in a way that can help us make decisions day to day on how we should be operating. On top of this, the historian technology generally comes with some kind of visual trend analysis, where as an engineer, I can select a tag and look at how that data has been changing over a period of time. And also there would generally be mechanisms for taking data from the historian and exporting it into tools like Microsoft Excel, so we can do extra kind of analytics or processing on that data. And for many of us, this is how our real-time operations, our digital oil fields, have worked for many years. And it's fair to say that this kind of setup has brought tremendous amounts of value. But one of the problems we've got is that in this kind of world, in this historian, the data structures are very flat. We're just talking about tags, simply unique identifiers, timestamps, and values. There's no concept of data context, data definition, data structure, nothing like that. So we really have some challenges when we start thinking about how we can use all this information in regards to new systems, new tools, new applications. Okay, so we're all familiar with this as our typical real-time operation, digital oil field, you name it. But increasingly, when I talk to our customers, what I hear is an appetite to do a lot more with real-time data. Customers want to start integrating their real-time systems with other critical business applications, maintenance systems, finance systems, engineering tools, this kind of stuff. And we all know there's a massive appetite in the industry for the advanced analytics, the machine learning, the AI, the digital twins technology, advanced reporting, augmented reality, you name it. All these fantastic new technology trends that everyone's really excited about. And on top of that, there's real interest in cloud technology. A lot of these analytics tools, digital twins, are deployed into the cloud. So there's a lot of questions that get asked about how does the real-time technology we've been using for a long time, how does it integrate with all these tools and all these platforms and all these systems? And I think it's fair to say that although the technical challenges of linking these systems together are really quite straightforward and can in many cases be done in just a matter of minutes, we need to really ask ourselves questions about, are our flat data structures, are our unstructured tag-based historians really the right foundations we need for supporting all these kind of advanced operations and tools and systems? And I think the answer is pretty much no, they aren't sufficient enough. And that's why over recent years, there's been a lot of advances in the real-time technology that we've all been using. But in many cases, many of us are either not using this technology or at least not aware that this technology exists. And maybe if we were, we could start using it more and we would get a lot more value from all these new technology projects and programs we're trying to undertake. So the first thing I want to talk about is making the data more meaningful to everyone and everything. And really what we're talking about here is introducing context and structure to our data. If we want to be able to integrate this data in a smarter way, if we want to be able to provide the analytics tools that we all want to use with focused sets of information that really help them produce the amazing predictive insights that we all want them to do, we really need the ability to be able to introduce some definition to our historian databases and bring some context and structure so that we can really start using this information in a much smarter way. So how do we do this? Well, the answer is quite simple. We layer on top of our traditional historian tools an extra layer, which allows us to define within a data model definition, libraries of templated asset definitions that we can use to define and create definition around those physical pieces of equipment that we see in our oil field. So whether we're talking about pumps or compressors or turbines, we can create libraries that allow us to define what those physical assets look like in digital terms within the historians. So we move away from the idea of tags and we move to attributes within templates that give meaning to the data and help everybody that's using this information to understand what they're looking at in a far more sophisticated or at least meaningful way. And once we have these templates, we can simply create hierarchies of these as physical representations or digital representations rather within this digital hierarchy that represents the physical world in our assets. In other words, what we end up with is a structured, meaningful, and consistent digital representation of our physical assets within our data layer. And what that means is that anybody in our entire organization that needs to get access to this information or operational data from our historians no longer needs to access this through the tag-based historian method, which is really quite confusing and not very accessible for many of us in our organizations. We can now come directly to the asset hierarchy and pull information directly out of these asset templates, which is a far more efficient way to make this data far more meaningful to an entire organization. But possibly even more important than that, what we can also make sure is that all our advanced analytics platforms, all our digital twins, all our data lakes, all these kind of tools that we want can also access our historian information through our operational data model, through the asset hierarchy and through the asset definitions. And this means that we suddenly have the ability to provide all these tools the context and structured information that is so critical to them. And I'm going to highlight the importance of this with an example from the world of digital twin. So we're all familiar with the idea of digital twin. We have our assets that are generating operational data second by second, minute by minute. And we have a piece of technology or many different types of bits of technology that generally is referred to as digital twin. And typically what we see within digital twins is lots of different types of operational information, maintenance information, finance information, 3D information, technical drawings, photographs, you name it, all the digital information that we have about this physical asset. And generally what we see in the digital twin is all this information is linked together in context. And this is really important because as an engineer, if I'm looking at one piece of information, I can quickly find other bits of information that relates to that first bit through those contextual links. And for as long as digital twin technology has existed, people have been interested in integrating operational real-time data. Makes absolute sense, right? I want to not only look at drawings and 3D models, but I also want to understand in real time how that particular asset is performing right now. But the problem is that all this information is, when I have no context or structure in my historian, when I'm reliant purely on tags, this information needs to be manually stitched together. It takes a lot of time and is really, really hard to keep up to date. But the problem is that our assets change. They change every day. We have maintenance activities. We have pieces of equipment being swapped out and changes. We have enhancements going on with our assets. And the problem is that what that means is that all these manually stitched together references generally start breaking quite quickly. and the digital twin information becomes less and less up to date and less useful. And engineers start going to this information and finding references breaking or unable to find the information they want. And they stop using the digital twin, which is a problem. Now, we've been talking about the data model being introduced into our real-time technology. Okay. Now, the benefit of the data model, as we were discussing a minute ago, is the introduction of context and structure. And what that means is that we now have a mechanism for the digital twin to start asking questions to the real-time data layer about things that have been occurring. So when perhaps that maintenance occurred, maybe when we changed out a pump, the digital twin technology may become aware that this pump has changed, and it can go to the real-time technology and say, are you aware of the new pump? Do you have the tag information for the new pump? Can you remove the references from the old ones? And by doing this, we have a mechanism of keeping in synchronization the digital twin with our real-time operation data technology. And this is critical to ensuring that that side of the digital twin can remain up to date, remain relevant, and of use to our operations teams. And this is just a quick example of why having things like context and structure is so important for our advanced operations. The next thing I want to talk about is the idea of building an integrated view of our operation, of our information. So when we look at the digital landscape that sits around real-time technology, sits around the historian, we see a variety of different tools, analytic systems, models, engineering tools, lots and lots of different bits of information. And the real challenge is when we want to start exposing all this to our operations teams is how do we bring this all together in a consistent, centralized way so that operations teams can have confidence that all this information is exactly what they need, is in one place, and they can understand it all in context to each other. Now, the thing that all this information has in common is all the results of all these analytics and data processing all comes from the source underlying data. So I think it makes a lot of sense to make sure that all the results from all this analytics is linked somehow together with all the underlying data, so that when this is presented to an engineer, they can see all this information in context with each other. And again, this is done through the operational data models. We create this idea of a single point of truth. So not only have we got all this information that we're measuring from our assets, in this case from a well, but we might also have a variety of other systems that are taking that data and using it to do certain kinds of analytics or processing, but we want to bring the results of that processing back and expose it through this single point of truth within the data model. And this idea of bringing all this data together into one place is a really critical way that we can make sure that our engineers are all bringing all the results of everything together and have confidence that they're working on the right information at the right time to make the right decisions. So let me give you an example of this. So in this case, we've got our well producing data, but within our data model, we may have lots of different types of attributes that are being derived from this information. We may have fields that are taking this information and improving the data quality of it. We may have information coming from other places that relate to the well, such as laboratory management systems. We might have calculations that we are doing in real time on the data streams as they're coming from the well. We might have information coming from well tests. We may have model results. We may have data coming from our maintenance management systems that relate to maintenance activity on the well. We could have allocation information. We could have production information. And we possibly have references to external dashboards or reports that are being driven from information from the well. But hopefully what you can see in this example is that we, within our real-time data platform, have got one single template that includes not only all our source information, but also includes the results from all these different systems, or at least referential links to the individual applications, so that as an engineer, I can go to this one place and find all this information brought together. I can see it all in context with each other, and I've got that single point of truth, which is a really important building block for successful advanced operations. The next thing I want to talk about is the idea of data quality. I think we all understand the idea that if we put bad quality data into something, that we are going to get bad quality results out. And it doesn't matter how good our machine learning models are, or our AI tools, or our digital twins. If we're feeding them with poor quality data, then we aren't going to get the results we want. So my recommendation here is to say, a lot of modern real-time data technology has some really fantastic tools for helping you spot problems with data quality, to be able to quantify the problems and be able to make recommendations on how things should be improved, whether that's possibly recommending other sources of data or making recommendations for how the data can be cleansed or improved. So my recommendation is really take the time to understand the data quality features and functionality within your real-time technology, and make sure that your data strategies are really building in ways to ensure that the data quality that you're providing with your new systems and tools really is as good as possible. The fourth topic I want to talk about is the idea of keeping the management of our data separate from our applications and our systems. Now, it's absolutely fair to say this is a personal choice. And primarily, as long as the kind of things we're talking about today, as long as the ideas of introducing context and structure and meaning to our data, of improving data quality, supporting things such as exception-based surveillance on our data, as long as those kind of things are taking place, that's our primary concern. But there are real advantages to keeping the management of our data separate from our applications and our analytics tools that are using that data to do all their wonderful stuff. So what are those reasons for doing this? Well, I think the first reason is to do with digital agility. No matter what any software vendor tells you, there isn't a single oil and gas operator out there that uses a single analytics platform or a single tool for their digital operations. The reality is that we all use hundreds of different systems and applications and platforms. We use different types of analytics tools. Maybe our subsurface team use one thing and our maintenance team use a different. So we need to support agility in our digital strategies. It's important that the same kind of underlying good practice data management can support systems and applications in many different areas of our organization. And by separating the data management away from those applications, we're able to support that. The second thing is that in many cases, good data management relies on close interaction with the owners of this kind of information, the operations teams. And so by keeping these things separate and doing our data management in tools such as historians that operations teams are very familiar with, we're far more likely to be successful with what we're doing with our data management. And the third reason is that we really want to try and avoid problems of data silos. The more that we move data management activities deeper and deeper into our architectures, into analytics platforms, into certain applications, the more likely we are to create data silos, different pockets of information in our assets. And this is exactly the kind of thing we want to avoid, because different silos of information ultimately mean that our engineers are spending a lot of their time finding different bits of information in different systems, rather than using their engineering and operational experience with all the data in one single place to improve the way we operate. So we really want to try and avoid this as much as possible. So we've had a really quick 20 minutes here, and I know we've only just skimmed on the subject of data management, but hopefully it's giving you a sense that this is a topic that possibly needs to be explored further. And certainly I would say we at OSIsoft are passionate about this topic, and we would happily come and talk to you any day of the week and explore ways that we can possibly bring some improvements to this area of your digital operations and hopefully bring some immediate value into your operations. So a few closing thoughts. I just touched on this a second ago. We need to support agility. There isn't a single solution out there. There is no silver bullet. If there was, we'd all be using it. But unfortunately, there isn't. So we need to support a variety of different tools and systems in our operations. As much as all those tools are fantastic, and they really are, my recommendation is it's important that we put as much focus into the underlying data strategies and data management as we do into those tools themselves. And if we do, we're far more likely to be successful. And building an operational data layer really will help us be successful. It will empower our organizations. It will make data more meaningful and accessible, and definitely will provide a way to bring in a lot more value from digital for the implementation of digital technology. So we started today by talking about the origins of real-time data technology, digital oil field, etc. We talked about data models. We talked about technology like PyAsset framework. We talked about the digital twin. We've talked about data quality, and we ended up talking about separating our data management and our applications. I hope you found this an interesting 20 minutes. I've enjoyed giving the talk. Here are my contact details. If I can help with anything or you'd like to link in with me, I'd be delighted to accept that. I hope you enjoy the rest of the day. Thank you very much.